Welcome, recruits, to Phase 8.2 of AP Calculus Bootcamp. Operation Volume Dynamics. Your clearance is verified for recruit eyes only. Today's operation covers topics 8.7 through 8.12, which accounts for 10 to 15% of your AP Calculus AB exam. Status. Mission Go. Here is your sitrep and mission objectives. We have 3 primary protocols. The extrusion protocol builds 3D structures from 2D territorial footprints using known geometric cross-sections. Disk revolution generates solid cylindrical volumes by rotating flush 2D boundaries around an axis. Finally, washer revolution executes complex hollow core volume calculations when a gap exists between the region and the axis. Your master directive is visualization over memorization. Do not memorize disconnected volume formulas. Every volume application on the AP exam is simply a limiting case of Riemann sums, representing the accumulation of infinitely thin 2D cross-sectional areas. Find the area of one representative slice, big A of x, and let the definite integral execute the infinite stacking. Phase 1 initiates the extrusion protocol for topics 8.7 and 8.8. The bounded 2D region is merely the footprint on the ground. The 3D solid is formed by geometric shapes standing strictly perpendicular to the base. First, define the base slice length spanning the footprint, then plug that length into the specific shape's area formula, and finally, integrate that area function across the operational boundaries. Memorize the cross-section arsenal shape profiles. Volumes can be formed using squares, rectangles, equilateral triangles, and semicircles. The area formulas dictate your integrand directive. Threat warning. For semicircles, the base slice length is the diameter, meaning you must divide the base by 2 to find the radius before squaring. Phase 2 initiates the revolution protocol. We execute a kinematic shift. Instead of building perpendicular shapes from the ground up, the 2D region is rapidly spun 360 degrees around a designated axis. Because the motion is circular, every infinitely thin slice of the volume is a perfect circle, making the 2D area of a circle your primary driver. Identify the radius, square it, multiply by pi, and integrate. Here is your tactical execution for the disk method. Deploy this protocol when the 2D region is completely flush against the axis of revolution. There is 0 empty space inside the generated solid. The radius, r, is exactly the physical distance from the axis of rotation to the bounding curve. Prepare for a target shift when revolving around other axes, such as y equals 3. Do not panic, and do not invent new formulas. The core principle remains absolute. You must execute a radius recalibration by calculating the physical distance from the new axis to the curve, applying top minus bottom or right minus left. Tactical execution for the washer method must be deployed when there is a gap between the 2D boundary and the axis, creating a hollow core. You must subtract the hollow inner volume from the solid outer volume. Threat level high. Do not compute the outer radius minus the inner radius before squaring. It is the outer radius squared minus the inner radius squared. When navigating complex airspace with washers on shifted axes, rely strictly on visual bracketing. Draw a line from the axis of revolution to the furthest curve to establish the outer radius. Then, draw a line from the axis to the closest curve to establish the inner radius. The origin of your radius vector is always the axis of revolution. The thickness decision tree relies on one rule. Orientation is law. Draw one representative slice perpendicular to the axis of rotation. If the slice is vertical, its thickness lies flat on the x-axis. Deploy the dx protocol and ensure all functions are in terms of x. If the slice is horizontal, its thickness lies on the y-axis. Deploy the dy protocol and ensure all functions are in terms of y. Adhere strictly to the rules of engagement for FRQ setup protocols. A correct final answer generated by a calculator yields 0 points without presenting the full mathematical framework on paper. You must explicitly write the integral sign with boundaries, the integrand expression, and the correct differential. Do not perform intermediate setups in your head. Review the operational matrix for diagnostic synthesis. Match your visual intel trigger to the correct tactical protocol, cross-section, disk method, or washer method to lock in your mathematical directive. Time for the after-action report. Let's debrief Phase 8, Part 2. 1. Visualize. Don't memorize. Volume is just the infinite accumulation of 2D areas. 2. Orientation is law. Lock down your slice direction immediately. 3. Radius lines always originate directly from the axis of rotation. 4. Avoid the washer trap by squaring radii independently. Status: dismissed. End of AP Calculus Unit 8 operations. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.